Welcome to another installment of Spring Tips. In this week's installment, we're going to look at Spring Cloud Gateway. Spring Cloud Gateway is a new technology that's designed to provide a lot of the same gateway-style functionality that you may be familiar with if you've ever used Netflix Zool. In this installment, we're going to look at some of the features that Spring Cloud Gateway provides out of the box, some of which you may not find in for example, Netflix's Zool. Now, the question may arise, of course, why did we create Spring Cloud Gateway if we already had Netflix Zool? There's a number of reasons. First of all, Netflix Zool itself has not really seen a lot of sort of evolution. It hasn't evolved, hasn't advanced very much in recent time. So we're not sure where the project is headed. We know that Netflix Zool 2 isn't here yet, and that was a release that was supposed to be more in line with what we were hoping to have, including support for an integration with reactive technologies like, for example, Project Reactor. And as a result, it doesn't have some of the features that a lot of people have been clamoring for, including support for proxying other kinds of protocols like WebSockets, for example, as well as a sort of more flexible component model. So a lot of these things that we want in a sort of integration and a solution, we don't have there. Also, and very understandably, also you'll find that Netflix Zool doesn't open source a lot of the really useful stuff, things like rate limiters, right? That's stuff that is proprietary to Netflix. It's the way they do it themselves. It may, of course, and it may not be the best solution for everybody, and so naturally, completely understandably, that hasn't been open sourced, and so we as a community have been forced to fend for ourselves there. Not a big deal, but that's one of those things you can get out of the box in Spring Cloud Gateway. So let's take a look at that. We're going to take a look at that today, but before we build an edge service, let's just build a downstream service to talk to, and in order to talk to it, in order to discover it and find it, we're going to stand up a service registry. So we'll do that first. We'll create a Eureka service here, just as normal, right? Hit generate, and we'll go to our IDE. Here we are. There's this. We're going to open this up in our IDE, and we'll make some changes to make it available so that other microservices, including the service that we're going to build and our edge service, our gateway, can find things, right? So first things first, we're going to make this an application, a Spring Boot application that runs on port 8761. We're going to say that we want Eureka to register itself with itself, and we'll say that is false, and we want to fetch the registry. No need, we are the registry, so we'll do both of those, or rather we'll not do those. I'm going to say @enable Eureka server. Now that should be it, right? We have here on the class path Spring Cloud Starter Eureka server. So we'll leave that as is and start that up. That'll be on port 8761. Now, once that's done, we can now build a customer service, something to talk to. Now, this service is going to use the new, latest and greatest sort of reactive bit. So 2.0 M6 for Spring Boot. We use reactive web, reactive MongoDB. We use Lombok, naturally. We don't need the Eureka server support. We do want Eureka discovery, so we'll bring that in. And otherwise, I think that's it. So we might, actuator, that's probably a good idea, right? So we've got those bits. Let's hit generate. And open this up, customer service. All right. So first things first, we're going to give this a name. Spring application name equals customer-service. And then customer service itself is going to participate in service registration discovery. Now, as of Spring Cloud Finchley, which is what we're using on the class path, we no longer need the @enable discovery client annotation, right? You've probably become accustomed to doing that. That's not needed anymore, but that is in place, right? So when we start this application up, it'll register itself with the service registry. So again, this is going to be an application to manage entities of type customer. Just a strawman example here, strawman domain. So we'll private string ID, private string name, let's say, @ID, @document. There we are. There's our entity. Now we need @data, @all_args constructor, @no_args constructor. These are all from Lombok. They synthesize constructors, getters, setters, toString methods, all that kind of stuff. And of course, we need something with which to manipulate instances of this type. So we'll create a repository, extends reactive Mongo repository, managing entities of type customer whose primary keys of type long, and then we'll save some data in the database. So it'll be an application runner init, and we're going to inject the customer repository here. and we'll say return return args, and we're going to say cr.delete all, then then we'll say flux.just a b c map to a new customer object here. So there's this null for the ID, L for the name, and then map that to a record that we save in the database, like so. All right, and then I'm going to say cr.find all, and then we'll subscribe. So system out print line. All right, good. So there we are. There's our data in the database. Now we want to have an endpoint by which to access this stuff, so we'll take advantage of the Spring Web Flex, the reactive web runtime inside of a Spring Framework 5. So we'll say router functions, router function, routes, return router functions dot route, request predicates dot get, and first endpoint, of course, is customers, right? So I'm going to say, given a request, we're going to return a response. So server response.ok.body. We're going to inject the customer repository here to do our work. So cr.find all customer.class. There's that, and we have some other routes as well. Let's clean things up, simplify things just a wee bit here. So get rid of all that. Good. And what else do we want? We want to get customers ID r okay dot body cr dot find by ID, and we'll say customer dot class. There we are. Good. And we want one more endpoint, and this one is going to be something that we can use to introduce a delay. So we'll just call it just that. We'll call it delay, and we're going to say, given a request, just hello world, right? Given a request, we're going to delay the elements by 10 seconds, right? There we are. And we're going to return this whole thing, this whole delayed publisher, as a response. So, okay.body. Okay, pass that back like so. There we are. There's our endpoints. Let's see if that all works. All right. There we are. Okay. All right, we can go to the console here. Curl HTTP localhost 8080/customers. Seems to be okay. Let's try a particular record here. We'll take this. There's a single record. Let's prove that the delay endpoint is working. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10-ish. There we are. All right. So there's our record. So that's all working. All of our endpoints are working. We'll look at why we need this delayed response a little bit later. Okay. But we've got now 3 different endpoints. We can use that as our our harness, if you will, our feedback mechanism. So now let's go build a edge service. So I'm going to go back to start.spring.io. We're going to use the latest and greatest Spring Boot. It's going to use the actuator. It'll use the gateway support. It'll use the reactive web support as well, of course. So reactive web. We want to use, what else do we need? We need the security support. So let's see here. Security. We need Redis support. And I think that'll do. I think that's enough. Let me check. Let me think about this here. We've got the reactive web support. We have security. We want the Hystrix support, the circuit breaker. And Redis, Webflux, all right. Oh, Eureka, naturally. We need that, of course. So here's this as well. Very good. And we're going to call this the edge service. And this will, of course, interact with our downstream customer service via the service registry, the very same one that we just stood up. So edge service, here we are. All right. So we have a new application. That's the edge service application. Our application is going to be a Spring Cloud Gateway project. And if you've used Netflix Zool with Spring Cloud, then you know that one of the nice things you can do is say enable Zool server and or enable Zool proxy, and it'll automatically set up routes for you on the edge service that map to the routes in the service registry. So we can get the similar effect. Let's first of all participate in service registration and discovery by saying, by giving it a name, and we also want to differentiate our port, otherwise we'll have a port collision. And we can get the same effect just by doing route, and then we can do discovery client route definition locator. So these, discovery routes, and of course, in order for us to configure this, we need a discovery client. We say new discovery client route definition locator. All right. Let's see what we get when we run this application. All right. Now, already I can see a problem. I can see a problem already because we don't have security, first of all. Well, second of all, did that instance work? So 8761, our service registry isn't running right now. Why not? Okay, I neglected to start it before we got into it, so there it is now. It's happy, the customer service is happy. We'll restart this. And it'll still fail for reasons I just mentioned, which is that we forgot to disable security for the moment. So let's go back and remove security from our build just for the moment. We'll bring it back in a minute, and we'll restart. All right. Run. Very good. So if we go here, localhost curl HTTP localhost 8081 customer -service /customers ecolo. Look at that. We have the customers being proxied from the downstream service, and of course that's load balancing aware. So that's the equivalent to the one-liner annotation in the Zool world, but we can do a lot more, right? There's actually a number of different ways to do more. There's actually a property-based mechanism as well. I happen to prefer the Java configuration DSL, so we're going to use that. And the way that works is you create a route locator object, so gateway routes, and you use the route.locator.dsl, and that looks like this. So routes.locator.build, and here is where we create our different routes. So let's create a very simple route, just a basic proxy first, okay? And this is going to be a endpoint that we're just going to call start. It's going to be a route called start that's going to match a certain predicate. And there's a number of things you can use here for predicates. You could say path, right? I want, whenever somebody makes a request to the edge service itself, I want that to be to match a path, /start, and so on. I could also do much more interesting things. I could do host, route predicates.host equals foo.com, and chain them together, right? So it has to equal foo.com, so wildstarfoo.com, and then go to /. But in our case, since I don't have any hosts or vhosts set up on my local machine, we'll just do that, okay? So there's our request predicate, and then we will need to make a request to an actual endpoint. So let's just, for now, proxy the happiest place on earth, start.spring.io/80. All right, so that's a basic proxy. We're not, when somebody goes to localhost 8081/start, they're going to get the contents of this as though it was rendered on this machine. So let's try that. Localhost 8081/start. There we are. There's our, some of the style sheets and other assets that are linked relative to the server there aren't working, but that is indeed the output from the actual web service, right? So we got all that for for free, and it's very, very quick. You can see the proxy doesn't slouch here at all. Notice that I had to specify the port. That's one thing that may trip you up. Remember to specify the port. Otherwise, it'll assume port 8080, which is, of course, or 8081 in this case, because that's the port that we're using. That's not what you want. All right, so that's a basic proxy. You can do other kinds of things here. You may remember that Zool can be made load balancing aware, so load balanced proxy, right? So here we're going to say that we want to get the customers, right? The DC, I guess we could say, or LB. There you go. Predicate will be path LB, and the URI is going to be LB : customer -service/customer. So we're actually now taking advantage of a Eureka aware URI, right? This is going to talk to the service registry. It's going to give us back the results, etc. It's going to do what we would have expected, but without having to spend very much time at all. So here we are. We said LB. There's the customers. What happened there is that the client went to used the Spring Cloud Discovery Client abstraction and went to the service registry, got all the service instances back, and then passed that to something like Ribbon. Ribbon did client-side load balancing, and we picked an instance and routed the request ultimately to that particular instance. All of that happened in the blink of an eye. So that's very convenient. Okay, so that's a very simple proxy. That works. But we can do more interesting things as well. We could, for example, introduce custom filters, right? So let's do that here. A custom filter 1, right? And we're going to say route CF1, and predicate will be path equals to CF1, and the URI will be load balanced customer -service/customers. But before we do that, we need a filter, right? There's a number of ways you can specify the filter. You can specify it one at a time, or provide them all in particular order. I'm going to do this one. And our filter will just be a very simple one. We're going to create a custom one by default. So we're going to say exchange chain equals, and our job is then to respond. So we're going to say filter, sorry, I'm going to say chain.filter exchange. In this case, we're just going to, it's just like the servlet filter API we're going to actually call recursively the other filters in the chain, and then we're going to process the response. So then, and we're going to say mono.from runnable, and we're going to say we're going to provide a runnable here that gets processed, that gets run after the processing of the of all the downstream chained filters, right? So we're going to do something like this. We're going to say exchange dot what are we going to say? Get response. Exchange dot get response. I'm going to store that in a variable there. So server HTTP response, good. And we'll say HTTP response dot status code, and let's just pick some, I don't care, conflict. Okay, there's that. HTTP response dot headers dot content type, media type, PDF. All right, so that's a very simple filter. So now, when somebody goes to /CF1, they should see that it doesn't return that status or that content type that we would have gotten from the actual service. And the actual service, you may remember, of course, we can get to by going to LB. So let's compare here. So LB versus CF1. If we go here to LB minus V for verbose to see the details there, it's HTTP 200 and content type is equal to application JSON. That's the original web service, basically. And here, we're going to use CF1. And you can see that we get 409 conflict, and of course the content type is PDF, which in this case, there's no rhyme or reason to this. Obviously that's nonsense. This is not what the actual service returned, and there's no reason to send it back in this case. I'm just demonstrating a point, right? This is that you can override or change the behavior of the responses there. So again, a gateway is a great place to address cross-cutting concerns. Concerns like authentication, authorization, zipping and compression, routing, anything you want to do in a cross-service way in a single place, you can do that here. Load balancing, all that kind of stuff lives here at the edge. This should be your first port of call for requests coming in from the outside, from your actual clients talking to your downstream services. So you can do all sorts of cross-cutting kind of thing here. Now, in this case, I used a custom filter, but let's look at a custom filter. Let's look at it, just using a regular filter, right? So we'll customize the filtering, but we're not going to provide our own filter this time. We're going to say route is equal to, let's see, what did I do there? Filter. Oh, right. That belongs to this one. Here we are. And here we'll say cf2 dot predicate path cf2, and the URI, of course, as before, will be the load balanced customer service endpoint, because why not? And what we're going to do here is we're going to take advantage of some of the pre-built, out of the box functionality here. So maybe I'll change this path. Actually, maybe I want the path to be cf2 ***, and we're going to say that the request is going to go to customer service just by itself, and the filter is going to be the rewrite path. So gateway filters dot rewrite path, and what we're going to do is we're going to use a regular expression to modify the request that's coming in, to modify the path of the request that's coming in to the edge, and then that path will be what's sent to the downstream service, right? So we could provide a path here, but that would be ignored, right? It's going to be replaced with whatever we substitute it with here. So we're going to say when a request comes in, we're going to say we want to capture this customer ID, and that could be anything. And there's our regular expression. There we are. Okay, and we'll provide a replacement. So I'm going to say instead the path should be whatever we captured as a customer ID in the previous segment of the path here will be substituted and extracted and made available here. So this is, if you've ever done Nginx, or if you've ever done mod rewrite or anything like that in Apache, this should look very familiar, right? And the fact is, you can have the same power here out of the box in your Spring Cloud Gateway. So let's example. So what's going to happen here? When you make a request to localhost 8081 CF2, the edge service, /*, passing in a customer ID. That's what CID is short for. I'm being cute for no reason. It's a customer ID. When you provide that, we're going to provide a grouped, a pattern group here, and we're going to give it a capturing name, and we'll then use that captured element and bind it to the replacement, right? So we're going to forward the request to load balanced customer service / customers / captured CID. All right, let's see what that looks like. So what did we get? That's the first one here. I'm just grabbing the ID of something. All right, CF2 paste. There we are. We can see we got the one record, right? We were able to make a call to localhost CF2 ID, and we got the response from the downstream service. So that worked. That we were able to change things. Right? You could chain these filters together. You can do all sorts of things, right? You can do very custom, very dynamic processing here. You could even store all those custom filters in the exact order that you want them in a list, as we thought earlier, and then just apply them to different gateway edge services or endpoints. All right, so that's I think a lot of that is what you'd expect. Let's look at some slightly more involved, slightly more interesting options here. One option is to use a circuit breaker, right? So we've got Hystrix on the command line, on the class path, and we can use that circuit breaker to protect requests that we make through the edge service to our downstream service. And anything that we can specify for Hystrix, for a particular Hystrix command, can apply here. So let's create a .route cb And the predicate will be, of course, just path CB, and the URL will be load balanced customer-service / customers, and the filter is going to be gateway filters dot histrix, and we're going to give it a command name. Let's just give it imaginatively enough CB. All right. So that's going to create a histrix command. It's going to wrap the invocation of the downstream service in that command. Now, what does that get you out of the box? Well, not much. I mean, it'll wrap your command, it'll wrap your invocation in that command, which you can then, which will then return an HTTP 200, for example. It'll give you a default response if something should go wrong in the call. But you can also specify things like timeout. You can specify how long to wait before you give a request a shot, etc. So you can have a lot of control here. You can do it per instance name. You can actually specify per circuit, per command, CB, specific configuration, or you can specify default circuit breaker properties. So let's do default circuit breaker properties here. I'm going to go ahead and specify histrix.command.default.execution.isolation.thread.timeout in milliseconds equals 5,000. Now, we see histrix.command.default execution isolation thread timeout in milliseconds equals 5,000. I think you can actually say CB as well. I forget the specific syntax, but we're just going to do default. That'll be the global setting here. That'll apply to everything. Once we've done that, instead of calling customers, let's call the delay endpoint. Remember our delay endpoint? Our delay endpoint is going to respond only after 10 seconds. So what we're saying here is that we want to time out and return the default response if it takes longer than 5 seconds. Obviously, these are obscenely large numbers. You're not going to have, hopefully, you're not going to have requests that take anything even close to 5 seconds. But I do this because I want us to demonstrate what's happening here, right? So let's see what that looks like in action. Okay, restart. All right, so let's make a request to circuit breaker, the endpoint. We're going to get a response. There you go. So we got a 504 gateway timeout. That's because the request took too long, right? So this, of course, is we're demonstrating what would happen if the service was down, for example, or if it was slow to respond. Obviously, the service is available right now, but it took too long. So we time boxed that request, and we got that default behavior. So you can do all sorts of interesting things here. You could then do what you see here. You can actually, then dot whatever, and then start processing the response, setting different headers, sending different responses, whatever, right? So a lot of options here. Another thing you can do to make your services more robust is to use rate limiting, right? So let's look at that, rate limiting. Rate limiter, and what we're going to do here is we're going to create a route called RL. It's going to have a predicate path RL, and the URL will be load balanced customer-service / customers, and we need to provide a filter. Now this isn't quite the same as the other ones. We have to actually configure a request rate limiter. So let's do that here. We're going to have a request rate limiter here. All right, RL, and it's going to need configuration in order for it to do its work. So we're going to say rl.apply, and we're going to give it some tuple full of parameters, which we can use. What you need to know is that request rate limiter factory bean thing is going to, that request rate limiter gateway filter factory is going to in turn depend upon a particular implementation of a rate limiter. Well, I happen to know that implementation is the Redis rate limiter, and that's why I have Redis on the class path. We're also going to need Spring Security, so we're going to go ahead and restore that. We'll talk about why in a second, but we have Redis and we have security. So we know that it's going to use a Redis-based rate limiter. The reason it's using a Redis-based rate limiter is because it's going to it's going to keep state, right? It's going to have to keep state. It's going to keep count, if you will, of requests made into the downstream service. It needs to know how to differentiate requests. I suppose you could make a rate limiting policy that said that all requests to this service should be capped at n requests per second, whatever. But this default implementation is going to expect a particular key, and so that key you can provide it any way you want. The key that it's using by default, and in the default Redis rate limiter configuration here, is, what is it? It's the principal. It's the security principal. So that's what we're going to do, is we're going to use the security principal to give it a key based on the name of the user making the requests. So we need to configure Spring Security for that to work. What this configuration says is we're expecting to get 5 requests per second with a burst capacity of 10. So that's a very low level. Obviously, some websites do 10 million requests per second. So this is just for a demo, right? All right, so let's do that. We're going to have to configure Spring Security, the first reactive Spring Security no less. So we'll say enable WebFlex Security. There's that. And we need to address 2 concerns: authentication, authorization, right? So good. And we'll say bean map reactive user detail service authentication, and we're going to say new map users dot with default password encoder. Okay, and build roles will be user, and the username will be user, because why not? Password will be PW. So there's a very simple authentication mechanism. We're going to use a user detail service, a reactive user detail service that has one user with the default password encoder with the username user and the password, and the role is equal to user. And we need now a authorization element. Okay, bean, and here this is going to expect void authorization. We're going to inject the server HTTP security. Let's see, security, and we're going to say return security.build. Let's just see what that gives us. Filter chain. There we are. That's the return value. Okay. Now security dot authorize exchange path matchers is going to be equal to a rate limiter. Right. So anything going to rate limit is going to be it's going to require authentication, but otherwise, in the exchange will be permit all. So everything else will be wide open. Just that one endpoint, the rate limited endpoint, will require authentication. We'll say end HTTP basic end. Very good. So there's our configuration. And that's just very basic reactive Spring Security. We actually looked at reactive Spring Security in our previous installment, so you should refer to that video for more details. With that said, I think we have everything in place, so let's go ahead and restart the application, and let's confirm that the basics work first. Right? That's all we're trying to do right now, is just to confirm that given an authenticated attempt or request, user pw http localhost 8081, and we said RL. So that works, right? We got no problem. We had no problem making those requests. Now, I can't make 5 requests a second with my hand here, actually. So I'm going to, for the purpose of demonstration here, I'm going to do something little ugly, but it'll work. We're going to create a client in the same Java process. This should obviously, if this was a test, it would live somewhere else. But I just want to have something hammering the service so that we can see the responses that come back. So we're going to create a very simple application runner, and in order to do it, we're going to need a reactive web client. So web client dot create builder dot filter exchange filter functions dot basic authentication user and pw, and we'll build that. Let's see. So it's our web client, and when we make those requests, we're gonna generate a number of requests. So our goal is to generate more than 5 requests per second, obviously. So we'll say flux.fromStream, and I think we can use something in the JDK stream library to generate a sequence of values. Int stream dot range 0 to 100, and we're going to flat map that response or that data. So the integer, we want it to be boxed. That's what it's complaining about. Stream of integer. It's not a stream of integer. It's a int stream by default. So we have to box it, and then we're going to say for each number, which actually we don't care about. In other languages we could just say that, but we'll say number, whatever. Who cares? So for each number, we want to make a request. So client.get.uri equals HTTP. We're going to call ourselves basically on our own port, calling the rate limited endpoint, and we're going to get an exchange response, and then we're going to map that client response into something that we can use. So cr.toEntity. We don't care about the payload. We want the string back, no problem. And then we want to map that. So we're going to map the response to a message, right? So string.format. The status will be this, and the body will be this, and we'll say re.statuscode value and re.getBody. All right. So there's our message that we've mapped, and now we just want to subscribe. System out, print line. All right. That looks okay. That looks like that'll give us what we want. Let's try it. Let's run this application, and we should see that while 5 of them get through for every second, not all of them do, right? There you go. So there you see one got through, most of them didn't because we're going a little too fast. There he goes. 5 got through at a time, and then most of them didn't get through. 5 got through at a time, etc. By the way, this is not necessarily sequential, right? I'm using the reactive support here, so by definition, every single one of these requests could have happened in concurrence or not. So the status code 429 is too many requests, right? So it's rejected. It's rate limited the request to the downstream service per user. If we were authenticating with a different user, then this wouldn't be a problem. All right, so we've looked at just a few things you can do with Spring Cloud Gateway. The application is kind of, fairly simple. I'm sure you can imagine a lot of things you can do beyond this. One thing that's worth understanding is that there are, of course, there's integration with the rest of the stack, in Spring Cloud. So you can see Spring Cloud Gateway is being used in other places, that the ability to manipulate the routes is very useful. There's also surfaced information about these routes. You can see here there are actuator endpoints. So if I were to go to this endpoint here, let's see, curl HTTP localhost 8081. There we are, right? So the actuator endpoints, I can manipulate these routes. I can interrogate them. I can manipulate them. I can do all sorts of things to dynamically add or modify routes in the running process. So these actuator endpoints surface that information. That's very convenient. We have just the beginnings, as I say, just the beginnings of the possibility, right? We've done a number of things here fairly straightforwardly. I've demonstrated a number of concepts here, but there's so much more, and I'm sure you can imagine them as well. So with that, thank you so much for watching, and we'll see you next time.